Now next is differentiation of implicit functions. Now first is, what is the meaning of implicit function? Now before explaining implicit function, first I will explain you what is explicit function. When y is written in terms of x or x is written in terms of y, that type of function is called explicit function. For example, that is your y is equal to fx. So this is your explicit function. So for example, this is your, let us say if I write down y is equal to mx plus c, that means it is explicit function. Or x is equal to fy. So it is x square is equal to y square minus 3. So this is your explicit function. So what is implicit function? In the implicit function, the values x and y occur simultaneously. That is, it is written in the form of fxy equals to 0. So what is the example of this? It is x square plus y square plus 2gx plus 2fy plus c equals to 0. This is the example of, that is your implicit function, in which the variables x and y occur simultaneously. I can write down this in the implicit form as y minus mx minus c equals to 0. Now it is written in the implicit form here. So now next question is to how to differentiate the implicit function, or what is the difference between this and the regular differentiation. So for example, we have, if ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0, then find dy over dx. This is the relation which is given to you. That is your, you must be knowing that it is the general second degree non-homogeneous equation. General second degree non-homogeneous equation. It can represent a pair of lines, it can represent a circle, it can represent any conic here. But now at the moment we are discussing the differentiation. So d over dx of ax square plus 2h times d over dx of xy plus b times, it is d over dx of y square plus 2g times d over dx of x plus 2f times, it is d over dx of y plus d over dx of c, this is equal to 0. A into 2x plus 2h. Now first function into the differential of second function plus second function into the differential of first plus b into. Now how to differentiate this? It is 2 times y raised to 2 minus 1 into d over dx of y. So this is going to be the only difference here. Now let me explain this point to you again. So the differential of x raised to n is n times x raised to n minus 1 into d over dx of x. It always comes out to be equal to 1. So we have, it is nx raised to n minus 1. So similarly, when we differentiate y raised to n, it will be n times y raised to n minus 1 into d over dx of y here. So this is the thing which you have to keep in your mind while differentiating the, that is implicit function. So plus b into 2y raised to 2 minus 1 into d over dx of y plus 2g plus 2f dy over dx, this is equal to 0. So separate the terms containing dy over dx. It is 2ax plus 2hx dy over dx, 2hy 2by dy over dx plus 2g plus 2f dy over dx equals to 0. Now this is one term, this is the other term, this is the third term. So 2 times dy over dx into hx plus by plus f is equal to minus of 2ax plus 2hy plus 2g. So what is dy over dx? It is minus of ax plus hy plus g upon hx plus by plus f. So your answer is also in the implicit form. That is, values of x and y are occurring simultaneously. So this way you can differentiate the implicit function here. Now for example, next question is, if x cube plus y cube is equal to 3axy, find dy over dx. So differentiating both the sides, d over dx of x cube plus d over dx of y cube is equal to 3a times d over dx of xy. 3x square plus 3y square into dy over dx is equal to 3a times first function into the differential of second plus second into differential of first. Now 3x square plus 3y square dy over dx is equal to 3ax dy over dx plus 3ay, or 3 times dy over dx is common, it is y square minus ax is equal to 3 times it is ay minus x square. So this implies that dy over dx is equal to ay minus x square over y square minus a square. Now I am repeating the fact that this was implicit function. Your answer, that is that of the differential, is also in the implicit form here. For example, next question is, if log of x square plus y square is equal to 2 times tan inverse of y over x, show that dy over dx is equal to, that is x plus y upon x minus y. Now from here, that is d over dx of log of x square plus y square is equal to 2 times d over dx of tan inverse of y over x. So differentiating both the sides with respect to x. Now 1 over x square plus y square into the differential of x square plus y square is 2 times 1 over 1 plus y square over x square into d over dx of y over x. So it is 1 over x square plus y square into 2x plus 2y dy over dx. This is equal to 2 times it is x square over x square plus y square into x into dy over dx minus y into 1 upon x square. You can see that this will cancel, this will also cancel, this will also cancel. So what do we have now? We are left with x plus y dy over dx is equal to x dy over dx minus y. So combining the terms containing dy over dx, it is minus y minus x, or dy over dx is equal to, that is your x plus y over x minus y, which is the required proof here. Now next is, if, what is the statement? Statement is x into under root of 1 plus y into under root of 1 plus x is equal to 0. Prove that dy over dx is equal to minus 1 over, that is your x plus 1 whole square. Now this question is different from all the previous questions discussed today. It's an implicit function, but your answer is in the explicit form. If you think that by straightway differentiating you can get this answer very easily, it is very difficult to get the answer. Very difficult. So, what to do? Now, we are given that x into under root of 1 plus y into under root of 1 plus x is equal to 0. So that means now our tendency should be to convert this implicit function to explicit function and then you differentiate this. Since these are two irrational terms involved here, take one of the terms to the other side. Squaring both sides. It is x square into 1 plus y is equal to y square into 1 plus x. It is x square plus x square y is equal to y square plus y square x. It is x square minus y square is equal to y square x minus x square y. Or x minus y into x plus y is equal to xy into y minus x. Or x minus y into x plus y is equal to minus of xy into x minus y. This will cancel. Now x plus y is equal to minus xy. So y plus xy is equal to minus x. Or y into 1 plus x is equal to minus x. That is y is equal to minus x over 1 plus x. Now before starting this question or solving this question, we had discussed that we need to write down this function in the explicit form. Now this is written in the explicit form as minus x over 1 plus x. If you differentiate this, it is minus d over dx of x over 1 plus x, which is minus v into differential of u minus u into differential of v upon v square. It is minus 1 plus x into 1 minus x upon 1 plus x whole square, which is your minus 1 over 1 plus x whole square, which is your required proof. So once again, you just have to keep this thing in your mind that although the function is written in the implicit form, but what we have to prove here is, or what the required differential is, since it is in the explicit form, so try to write down first the function in the explicit form and then you differentiate this, you will get the answer straight away. Now next is, if cos inverse of x square minus y square over x square plus y square is equal to tan inverse of a, then prove that dy over dx this is equal to, that is, y over x. Now if I try to straightway differentiate this left hand side, differential of the left hand side is going to be quite complicated. Now, can I write this as x square minus y square over x square plus y square is equal to cos of tan inverse of a? Now this is constant, that means its differential is going to be equal to 0. So d over dx of x square minus y square over x square plus y square is equal to d over dx of cos of tan inverse of a. So v into differential of u excuse me. Excuse me. So this implies x square plus y square into 2x minus 2y dy over dx minus x square minus y square into 2x plus 2y dy over dx. This is equal to 0 because cross multiply this, it will be equal to 0. So which means that 2x cube 2xy square minus 2x square y dy over dx minus 2y cube dy over dx minus 2x cube minus 2x square y dy over dx plus 2xy square plus 2y cube dy over dx. This is equal to 0. Now see if any of the terms cancels or not. This will cancel. This is 2xy square, this is minus 2x square y, this will cancel. Now 2xy square plus 2xy square, this implies 4xy square is equal to 4x square y dy over dx. This cancels, this cancels, this cancels. So this implies that y over x is equal to dy over dx, which was the required answer here. Now next is if sine of y is equal to x sine a plus y, then prove that dy over dx is equal to sine square a plus y upon sine a. Once again you can see here, this is your function which is in the implicit form, and what we have to prove here is in the explicit form, and answer is in terms of y. So from here can I say that x is equal to sine y upon sine of a plus y. Now d over dx of x is equal to, that is your d over dx of sine y upon sine of a plus y. So 1 is equal to sine of a plus y into d over dx of sine y minus sine y into d over dx of sine of a plus y upon sine square a plus y. So 1 is equal to sine of a plus y into cos y dy over dx minus sine y into cos of a plus y into dy over dx upon sine square a plus y. Now cross multiply the terms here. So sine square a plus y is equal to sine of a plus y cos y minus cos of a plus y into sine y. This whole is multiplied by dy over dx. So it is of the form sine a cos b minus cos a sine b. This is sine of a minus b. So what is the final answer? This implies that dy over dx is equal to sine square a plus y over sine of a here. So on daily basis what we are doing here is, it is definitely going to help you in competitions. For board level, if you do all this work, I am 100% sure you will be able to score more than 95% of the marks, or more than will be able to score more than 95 marks, and more than 100%. This is going to help you in your competitive exams also. These type of questions in general are not asked at your board exams, but is going to help you for your competition also. But if you prepare of this level, will surely help you in your board exams. Now next is, if under root of 1 minus x6 plus under root of y minus y6 is equal to a into x cube minus y cube, then prove that dy over dx is equal to x square over y square into under root of 1 minus y6 over 1 minus x6. So once again, do not try to straightway differentiate this function. Since when the function involves terms of the form a square minus x square, put x is equal to a sine theta. So accordingly, put x cube is equal to sine theta and y cube is equal to sine phi. 1 minus sine square theta is cos square theta, so cos theta plus cos phi is equal to a into sine theta minus sine phi. CD formula: 2 cos c plus d by 2 into cos of c minus d by 2 is equal to a into 2 cos c plus d by 2 into sine of c minus d by 2. So this term will cancel. So this implies tan of theta minus phi by 2 is equal to, what is that, 1 over a. So this implies that theta minus phi by 2 is equal to tan inverse of 1 over a. This implies theta minus phi is equal to 2 tan inverse of 1 over a theta, or this implies from first sine inverse of x cube minus sine inverse of y cube is equal to 2 times tan inverse of 1 over a. Now you differentiate this. So it is 1 over under root of 1 minus x6 into 3x square minus 1 over under root of 1 minus y6 into 3y square dy over dx. This is equal to 0. Or this implies that 3x square over under root of 1 minus x6 is equal to 3y square over under root of 1 minus y6 into dy over dx. Or this implies that dy over dx is equal to x square under root of 1 minus y6 over y square into under root of 1 minus x6. X square into under root of 1 minus y6 over y square into under root of 1 minus x raised to power 6, which was the required proof here. Now next is if x square plus y square is equal to t minus 1 over t and x4 plus y4 is equal to t square plus 1 over t square, then prove that dy over dx is equal to 1 over, that is your x raised to power 3 into y. In this question, the implicit function is written in terms of the parameters. So we need to first eliminate, that is your t here. Now can I write down x4 plus y4 as t square plus 1 over t square, which is your t minus 1 over t whole square plus 2. What is the value of t minus 1 over t? Which means that it is x square plus y square whole square plus 2. That is your x4 plus y4 plus 2x square y square plus 2. So these two terms will cancel and we have x square y square plus 1 is equal to 0 here. Now can I write down x square y square is equal to minus 1 or y square is equal to minus 1 over x square? So 2y dy over dx is equal to minus d over dx of x raised to power minus 2, which is 2 times x raised to power minus 3, which is your 2 over x cube. Now this 2 will cancel. So what is dy over dx? It is 1 over x cube into y here. That is the required proof. Now next is, if y into under root of x square plus 1 is equal to log of under root of x square plus 1 minus x, then show that, what is that? It is x square plus 1 into dy over dx plus xy plus 1 equals to 0. Answer is in the implicit form, function is in the implicit form. So straight we differentiate this. So it is d over dx of y into under root of x square plus 1 is equal to, this is d over dx of log of under root of x square plus 1 minus x. So first function into the differential of second plus second function into the differential of first is equal to 1 over under root of x square plus 1 minus x into d over dx of, what is that, under root of x square plus 1 minus x, y into 1 over 2 times under root of x square plus 1 into 2x plus under root of x square plus 1 into dy over dx is equal to 1 over under root of x square plus 1 minus x into, so 1 over 2 times under root of x square plus 1 into 2x minus 1. So this will cancel. So what is that? It is xy over under root of x square plus 1 plus under root of x square plus 1 into dy over dx is equal to x minus under root of x square plus 1 upon under root of x square plus 1 minus x into 1 over under root of x square plus 1. Can this be written as minus 1 over under root of x square plus 1? So, question was to prove, or this implies xy plus x square plus 1 into dy over dx is equal to minus 1, or xy plus x square plus 1 into dy over dx plus 1, which is equal to 0 here. Now next is, if e raised per x plus e raised per y is equal to e raised per x plus y, then show that dy over dx is equal to minus, this is e raised per x into e raised per y minus 1 over e raised per y into e raised per x minus 1 here. Now again you can see here what we have to prove here is it is in the implicit form. So from here, d over dx of e raised per x plus d over dx of e raised per y is equal to, this is d over dx of e raised per x plus y. So it is e raised per x plus e raised per y into d over dx of y is equal to e raised per x plus y into d over dx of x plus y. So what is that? It is e raised per x plus y into 1 plus dy over dx. Now combine the terms containing dy over dx, so dy over dx into e raised per x plus y minus e raised per y. So can this be written as e raised per x minus e raised per x into e raised per y is equal to dy over dx into e raised per x into e raised per y minus e raised per y, or e raised per x into 1 minus e raised per y is equal to dy over dx into e raised per y into e raised per x minus 1. So which means that dy over dx is equal to e raised per x into 1 minus e raised per y over e raised per y into e raised per x minus 1, which is your minus e raised per x into e raised per y minus 1 over e raised per y into e raised per x minus 1.